I change the a of n to a of 5. That means that 5 has to go where the n is. The a of 1, I'm just going to change to a of 2 because that's the other term that they gave me. So a of 2, that now changes to 2. So then I plug in my numbers. I know a of 5 is 2/3 equals negative 8, because that's the second term, of r to the third power. I add 12. No, I divide negative 18 to both sides. And I should get negative 1 over 27. But I have equals r to the third on the other side. This is cubed. I need to take what to get rid of it? I have r cubed on one side. I need to just be r. I need to take the cubed root of both sides. And I should get r to be negative 1 over 3. Like so. Okay. What's my next step? I still need to find the 16th term. So that's done. This is first step. Find r. Done. Now I need to find 16th term.
What's the equation to the left?
This one? This is our standard geometric equation for a formula, like finding the nth term. Because it's supposed to, and I just did write it. It should be r to the n minus 1. Okay. So I take my original equation. Now, Christina, I don't have my first term. So let's not use our first term. Let's use our second term, which we know. So our second term is negative 18. That changes this to n minus 2, to a of n. We're trying to find the what term? 16. So that's now 16 equals negative 18, which we know what r is. What's our r? Yep. Up here is now 16 minus 2. Okay, you got it. You can do the rest.
Negative 3.76.
3.5, yeah. You just move it back 6 decibels. I mean, move it forward.
Will it give you a fraction for it?
No.
Okay, well, we found the number. Just saying put it. Okay. That is not the end of geometrics yet. But I think it's the end of this for a second. Oh no, we still have a whole nother block. Switching it over. This is still 9.3. Continues. I'm going to that. I'm going to do dot dot dot. We are still continuing. We should be done with this today. There's not much left. And we have series, which we have already done. So, we want to find next the sum of a finite geometric series. Sequence. We're sticking with sequences for now. But we're finding the sum. We're kind of almost talking about series already. So, I'm going to give you a hint. This is going to be an equation. This has a form with a common ratio. Common ratio is our r. And our r cannot equal 1 in this case. So the sum of a finite geometric sequence is given by, well, we're doing sum, so it's Sn equals A over I. We're going to start with 1. We have our first term. We have R to the I of negative 1. That is mostly left out in most equations. It's still negative 1. This can also equal to a nicer version of this formula is A of 1. Oh. This all equals out to A of 1 equals 1 minus R of n over 1 minus R. That's a nicer version of this formula. Because we're talking about finite geometric series. So let's do an example. Let's say we have ten up top. We want the sum from 1 to 10 of 2 of 0.25 I minus 1. I can only do it if it's I minus 1. Then I can use this formula. If it's not I minus 1, I can't do it. I need I minus 1. Okay. We need 3 things. I need my first term, I need my n, and I need my rate to use this. What is my first term? Yep. It's going to be 2. 2 times 1 minus, what is my rate? Yep, wait. So it's 0.25, and I have to raise it to the what power? 10, because that's what I'm going to. That's 1 minus 0.25. This is going to find me the what term? What term are we trying to find right now? 10th term. So this is going to give me the sum of the first 10th terms of this geometric sequence. So that's how I got n from up above. Try it out. Grab a calculator. Everyone grab a calculator. Dylan, what did we get for our answer?
2.6666664 5 6.
5, 6? Okay, I'm just going to round to 7. 5, 6? Okay, so then it's just 6. Boom. Okay. Is it 2.6656?
No, like there's 5 6.
Oh.
Yeah.
Okay, so then it's 7. I'm going to stop there. I'm going to call it a day for that decimal. Yes, that would be the answer for the sum of the first 10 terms in this geometric sequence.
What's the difference between a sequence and a series?
So a sequence is just the numbers. a series is adding up all the numbers. So we're talking about a sum of this. Like this is, we're now doing the series. We're doing the sum of it. It's just like a leeway into series. So if I have like 1, 2, 3, 4, if I add all those numbers up, I have my series. Series is one number.
So series is the sum.
Yeah.
Okay. Then why did the questions ask us to find the sum of the series? Isn't that the same as sum of the sum?
Yeah, fine. Yeah, it just, sometimes they put infinite up here, but yeah, this notation means series. Like you're just doing the series, but sometimes they want you to say sum of this. I don't know why. They mean the same thing. Yeah. So that's finite. Let's go to infinite. So sum of infinite sequence. I'm just going to do infinite geometric. And we'll do series. Series. So I already gave you this before. If my rate, the absolute value of my rate, is less than 1, then the infinite geometric series has the sum. Anyone remember what I gave you before? I'll start it off and see if you all remember the equation. I equals 1, no, I equals 0, start 0, of a1 r to the e equals an equation. This is back from 9.1. I gave this equation early so that you all could use it because they were all geometric, and I don't want you to do it the long way, giving me not much time. We took our first term. We put it in the top. What goes on the bottom? Yep, 1 minus our weight. You all use this in 9.1. I gave you it a little bit early because all of them were geometric. This is our equation, so we're going to go through this fast. I'm going to give you 2 problems because you already did these exact same problems before. So infinite, so I get n equals 0 of 5. My rate, and my n is up top because it is geometric. I want you to find the sum of this series. N equals 0. Yep. Okay. I will also look up here. Oh. Ooh. Okay. Anything raised to the 0 power is what? 1. So raised to the power, so we have 5 and 1. So this equals 5. So that's my first term. Over 1 minus my rate, which is 0.5. This should equal our 10. So let's do... Ooh.
That's what I did. I didn't get it.
I need a better calculator.
Oh, wait.
Let's do it. Alpha. Fractional. I
Now
have...
I got 10.
What did you do different?
Parentheses.
Ah. This, I always do the fraction button on the calculator so I don't have to worry about parentheses. So this should equal 10. Okay, I'm going to give you the numbers now. 5 plus 1 plus 0.2 plus 0.04. There's 2 ways to find the sum of this. Well, we'll just do one way. Dot, dot, dot. this time I gave you my first term. What do you need to find first?
Wait, what are we trying to find the sums?
Yeah, the sum of the infinite geometric.
Oh, the infinite?
Well, yes, this is infinite. It keeps going on and on. Yes. So what would you have?
Right? This is that's our old system, right? Okay. If the first one plus 0, this will be a first of 5.
So what's the first term?
5.
5 over 1 minus r. We need to find r. How do we find r? Yes, so geometric, so we're doing a constant ratio. So we take our second term divided by our first term, should equal the same thing. Our third term divided by our first term equals the fourth term divided by our third term. They should all equal the same thing. And what does this all equal? What is it? Yes, 0.2. So this should be 5 over 1 minus 0.2. And what does that equal? 6.25. When you added these all together, what did you get?
6.24.
Isn't that super close to 6.25? See, because it just keeps getting smaller and smaller and smaller. Yep. Cool. So that is the end of the final. We are doing an applied problem. I am going to write it up on the board. Okay, you put, remember our exponential growth and decay stuff? Yeah, welcome back to it. Okay, you put $100 into an account. With 6% interest. And let's have it be compounded monthly. On the first of each month. You don't really need that fact, but now you have it. How much do you have after 4 years? Okay, does anyone remember how we first start these equations? Okay, what's our principle? Yeah, the rate written as a decimal. How many months in a year? 12. Yep. And then what is our time?
4 years.
Yeah, so 4 years times 12 because we want it in months. So that's 48 months. Ooh, months. So I should be putting 48 up top. So if I'm talking about series right now, this is a of 48. We have an exponent up in the top. Lovely. We want to find out how much do you have after 4 years. So this is my first deposit. My second deposit, this is the start of my years, will be 101 plus 0 point, same thing, except now I'm down a month. I have 47. And it keeps going on and on and on until we get to our very first, very last of our last deposit. 100 over 1 plus 0 0.06 over 12 over 1. And that is the very first one. Putting $100 every single month for 4 years. And it's earning 6 interest compounded monthly each time you put it in. So each time you put it in, you're going to earn more than 6% than you did before. Put more money in, you get more interest out. So I want to find the total of it after 48 years. So I need to add every single one of these up, all 48 of them up across the entire time. So I'm trying to find what? I'm going to try to find the sequence, the sum of the sequence, the series. Yep, it is finite. So technically we say sum of a finite geometric sequence. Since, yeah. Or the series of this finite sequence. Yes. So what equation helps me find the sum? Yes. So we have A1. Oh, A1. What did you say it was again?
Oh, I think I said that.
That's the infinite.
Yes, I have finite. I have 1 minus r and 1 minus r to the n. Right? Okay. What do we know so far? How long do we want to go for? 48. Okay. We need to find my first term, and I need to find the rate. That's what we are currently missing. Well, I'm pretty sure we already set up something that will help us find the very first term. So, find the first term. Alright, so we got 100.5. That's after the first month. What is my rate? Close. If I do a 0.06 each time, it's technically decreasing because you're only getting. I want a. Yes, but we're missing one other part of it. Where are you getting it from, Nolan? Yep, I want everything inside parentheses. Don't just take a chunk of it. Take everything inside. That's the rate. This whole thing is R. So I have 1 minus, Dolan, did you calculate it already? Yeah.
Oh, wait, the whole thing?
Just, no, just the rate. What's the rate?
1.005.
1.005. Okay, that's over 48. Sorry if it looks a little messy. 1 minus 1.005. Boom. Okay. Let's all individually put this in our calculator so we know how to put them in the calculator. So 100.5 times my gigantic fraction. 1.
Oh, is that after you multiply?
Oh, yeah. 5,436.
Oh, okay, multiply.
I like this number. What is this telling us?
The sum of the finite series.
Yes. And we went for how long in our finite series? 4 years. So this is the sum of the account after 4.
Where'd the 48 come from?
48 months is in 4 years. Yep. After 4 years, I would put it back to years. Boom. done.
Thank you, Bravery.
Yeah, you all seem a little tired.